Okay, welcome to this forensics investigation session on Windows Registry. What I want to do is I want to talk through a little bit about the registry associated with Windows, and we're going to cover some new concepts that are all sort of fairly linked. One tends to think of the registry of a Windows system as being what you are presented with when you use an application such as regedit. And that information that you're presented with happens to be stored on files on the Windows machine. So we're going to look at what files, those files store their data. Could refer to those as being databases. Those files are also referred to as being hives of information. We're going to have a look at where those are stored, and we're going to have a look at the sort of information you can extract from them. But just before we do that, let's have a quick look at the history associated with the registry. So before Microsoft had built the registry into the system, so on Microsoft disk operating system, DOS and Windows 3 point something or other, there are a load of initialization files called ini files, system ini files, win-ini files. Each application had its own ini file, and these ini files were text-based files. They were really quite easy to edit. So anyone was able to look at the information stored in any file, and they can then edit that information. So this wasn't particularly good, and one of the reasons why it wasn't particularly good is because there was a large number of them, depending on how many applications you had. It was relatively slow to access this information. Any files were all storing similar types of information, but storing it in their own file. There was no standard for the types of any files that were being generated by applications. There's a fragmentation of data across the system. That data might not be consistent depending on when the application was last run. And there was also a lack of network support for this. So if an IP address had been associated with a system, that couldn't be statically written into the ini file. So Microsoft decided that actually it would be a good idea to extract all the information, particularly associated with a system, associated with a user, and all the information an application wants, and to store that in something that they want to refer to as being the central database. So they wanted to take all of these initialization files and have somewhere to store them. And we refer to that as being a registry. So users are registered against a registry, applications are registered against a registry, and they're able to put in information, change information in the registry associated with themselves, and also extract information particularly about the system, or if it's an application, perhaps about the user. Now, that means that our registry gives us lots of information. Now, on the image that you've been given, as you'll run through the lab for this session, you'll identify the fact that you're able to extract stuff like the system configuration, what devices are installed on the system, what's been plugged into the system, what users are on the system, what their settings are, what URLs have been visited, so web browsing activity, what's been cached, files that have been opened, what programs have been executed, because there's also timestamp information on registry data. You'll also find when those programs were executed, and you also find information associated with passwords. So this is sort of Microsoft saying, okay, let's centralize all of this initialization information that applications might want to know what sort of system they're running on, what sort of users are on that system, to ensure that those applications can be configured correctly. Now, on Windows 95, 98, the registry system was quite simple. So there was a system.dat file that was located in root/Windows, and there was a user.dat file located in root.Windows, and if there are multiple users, then each individual user had their own user.dat file that was stored somewhere slightly different. But the system file stored all the information about the system, about the programs, about the settings of those programs, and the user file stored all information about the users. And now I'll refer to these two files as so system.dat as being a hive, and the user.dat as being a hive as well. And these hives will store information that then form a part of the Windows registry. And then from Windows XP and onwards, we had six files that are associated with the Windows system here. And the very first one is ntuser.dat. Now, the location of this file is given there, and on the image that you want to that you're going to be investigating, you have to extract that ntUser.dat file for whatever users you're going to investigate, and that will give you a lot of information about what files those users have looked at and what their settings are for their particular preferences. We then have a default hive, and the rest of these, the SAM, security, software and system hives, are all stored in root Windows System32 config, so you can extract them from there. And your default hive contains system settings, your security account manager, so your SAM hive contains user account management security settings. Your security hive contains other security settings associated with the system. Software hive contains all the installed programs and their settings, and the system hive contains system settings. Now, I'd recommend you have a look at all of those to see what information is different in each of those hives from each of those files. So how this information is going to be used by applications and stored in the registry. Now, if you were to look on a Windows system and run an application like regedit, you will see that the registry is organized in 5 roots, and it calls these root locations keys, and there are also sub-keys that are stored underneath these roots, so imagine this being a directory structure. And our roots are root, current user, local machine users, and current config. Now, each of these root keys, as you navigate through the menu in something like regedit, you will see that lots of information is stored for root associated with, well, file types and what application is going to be used to open that file type, with what information you're able to extract about a user, when that user is logged in, what their profile settings are. Hardware settings, configuration information on the local machine, all of the user profiles you can get access to through the Hive key users, and then current config contains information about the hardware profile used by the computer during startup. And as I said, there are also a set of sub-keys that are essentially stored under these root keys. However, you need to appreciate that what you're doing from a forensic point of view is you're extracting these files that we referred to earlier here, these hives, and you're going to extract the information that will be stored within the registry directly from these hives. Now, what you might see when you extract this information is something called a security identifier, and here's an example of a security identifier. It's a long sequence of numbers, and these subparts of the numbers have specific meanings. Probably start off with something which is mildly interesting, which is this sequence here, so 21 ending up in 820 over here. And that's an identifier for whatever domain this computer happens to belong to, or it's an identifier for the local computer if the local computer doesn't belong to a domain, or if the user that this is identifying doesn't belong to a domain. And then at the very end there's a relative ID that is a unique identifier for the group or user that is using the Windows system. Now, with the information we're able to extract from the registry, registry keys actually have a last modified timestamp, and this is stored in the structure which is shown here. It isn't accessible through regedit. It is accessible through the binary files that you're extracting, through the Hive files that you're extracting. And the dates, of course, we're not using Unix epoch time, we're using the number of 100 nanosecond intervals since January the 1st, 1601. And if someone could tell me why they use that number, I'd be very interested, but maybe that's because I'm used to epoch time. So you can actually have date time information associated with each of the registry key, with each of the database entries that are stored within the registry. So what can we do in terms of analyzing the registry? Well, we can perform some sort of graphical user interface based live systems analysis, so you can sit down at a Windows computer that is currently turned on, open up regedit, and actually have a look at all of the Hive information, actually have a look at all of the information that's stored there. We can perform command line live system analysis, so we can do exactly the same thing. It's referred to here as being less risky, but in essence you're interacting with a live system, which is probably something that we don't want to do, nor do we particularly perhaps need to do it when we're able to extract this from a dead system, from a capture of the hard drive. We could also do remote live system analysis if we want, or we can do offline analysis, so we can perform analysis on registry files that we've captured from a hard drive image, which is what in essence we're doing for this lab. And one of the things that you've been asked to use is something called Registry. It is an open source registry data processing tool. It will take the Hive files that you're extracting from the image. It will produce a nice text-based report. It is available for Windows and it is available for Linux. There's a lot of information that you're able to extract using Registry. If I just show you, I'm on a Linux system here, of course. I have all of these plugins that I'm able to use in order to rip out information from whatever Hive I'm currently working on. Now, all of the example images given here are using something called regedit. So you'll see on the example there's a registry editor, and we'll see that we're currently on, okay, our root is current user. We're in an area called software, Google Toolbar 4.0 whitelist. And we get an idea about some information. So we have the data that is associated with the keys, and then the directory path, or the key path of this data that is being stored. So we can see here that we're able to extract some information and get an idea about some websites that exist on the whitelist of this Google toolbar. We can see some time zone information, and if you remember the very first video that I did, I talked about control set information, and I referred to something called the current control set and said it would be a good idea for you to look that up. So your control set information in your registry stores lots of information about how the system is currently set up, what configuration the system currently has, how the system was last booted safely, and how the system was last booted. And it also contains some time zone information and some information like last shutdown time. So you can see in this little snippet here, which is again given from a regedit view, we've got some information on whatever time zone we currently happen to be in. And there is something in the registry called user assist, and user assist is something that is there to populate the start menu of Windows system. So it maintains lists of programs that are run, the last time they were executed, how many times they've been executed, in order to give you a start menu that is most appropriate for how you work. Now it is possible to look at this information. Again, this is given from regedit, and you can see here that you can find, well, when this program was last run, so all of these here, so 2012, 2013, and what was the run path of the program that was run. So explicitly what executable file, what binary file was executed, and when that binary file was executed on the system by the user. The registry also keeps a record of the wireless networks that you've connected them to. It happens to label them preferred networks, so when you're searching through the text files that are generated by regrip, there's some text you might want to search in. And this will keep a name of the network, IP address and subnet mask, and of course this is useful because it could, depending on what type of IP address it is, it could give you an idea of what networks the computer has connected to. And I believe I have an example of one here. So here's an example of a network that the machine is connected to, and we can see, well, this is really quite interesting. It's a 148.197, which means it's connected to the University of Portsmouth network. And we can see what IP address has been allocated to it, what domain name server was being used, which is all quite interesting information. Windows also stores the most recently used files, and you can extract these from the user information, and that will give you an idea about what files the user has recently used, and also you can extract from the user information from the user hive information about Internet Explorer. So Internet Explorer is quite integrated into the Windows system, and it stores a lot of stuff like your logon password, search terms used, settings, whatever typed URLs you've had. And I believe I have an example of this here, where I have a set of typed URLs that have been typed into Internet Explorer. Now, I then have, my apologies, a little about the system. So the system hive that you're able to extract, here's some information that you can extract from it. The computer name, what disks, the install date, last user logged in, mounted devices, the product key, what owners registered to it, the programs that are able to run automatically, any USB devices. And we can sort of have a look at some of these here. And this is an example of, as you can see on this side, so we're on a local machine, system, mounted devices, and we can see identifiers of devices that have been mounted on this particular Windows system. And we can also see some identifiers for USB devices that have been plugged into the the system, and some examples here of what type of USB drive it is. System will also store some things like recent documents, recent commands that have been executed, startup software, which may be a good place to look for Trojans if you're having to be doing some analysis on a Windows system that is assumed to have been to have a Trojan running on it. And there is also some information that can be extracted from IntelliForm, which is an autocomplete feature for helping you fill in forms. Again, the values are stored in a particular key, so a particular database, and this is only visible to a student system account, but of course you're able to identify and extract this from the image that you've been provided with. Now I'll finish off this session with a little bit of a case study. And this is taken out of Windows Forensics book published by Wiley. And the case study is the department manager has alleged that an individual has copied confidential information onto a DVD. However, no DVD burner was issued, nor was one found. That individual's laptop was analysed, and of course in Registry they found a USB device entry for what appears to be a DVD writer, so a Plextor device. There was also a software key for some software that is able to burn DVDs, and that was found in Registry. Then they were looking for a load of other files, so Nero compilation files and ISO image files. Image files contain DVD format and AVI format versions of copyrighted movies. So there wasn't any evidence that this individual happened to have copied confidential information to a DVD. However, there was evidence that the user had copied material that was copyrighted onto a DVD and unfortunately had lied. So I hope you get on well with the laboratory this week, and that's it for the day. Thanks.